What up, everybody? Alex here. Now, I recorded, this is the third time. Okay. Hi. Welcome to the next edition of the Kingroon thing. Oh, and hey, new people, I include these rants for humor, flavor, and backstory. If you don't want to deal with them, usually this is what comes at the beginning of my video. You can go ahead and skip it with the time index in the video description. I'll do it high quality once. I'll try it again, but if it gets to a third time, then you get bad lighting. I don't turn the fans off. I can't get the stupid curtain to go all the way over because it's stuck on something over there. So what happened was FedEx screwed me yet again. When they're not dropping oscilloscopes and leaving them on the neighbor's doorstep in the rain, they're sending things a week late that are literally 40 miles that way, still charging me full price, and then on the little receipt thing that says when they dropped it off, so you get all the tracking information, backdated it and deleted all of the, like nondescript cannot deliver stuff. Deleted all of that and said it was delivered on time 4 days ago. No, you're dirty. And do I get a refund? Do I get an apology? No. So what you get is, anyway, yeah, so I ordered some parts thinking it'll be worth it if I can get these here quickly in time for the video. That will be value add because I can put a whole new segment in there and answer some questions that folks asked in the So in the meantime, what I'm going to do is take some of the B-roll and some of the things that I did for that video, kind of lump them into this one. So we'll keep this one to like 25, 30 minutes. The next one's probably going to be pretty long because I really just want to shove everything in there. Oh, and I'm going to splice in like face video from those previous attempts at recording this, so yeah, sorry if the background changes or my hairdo changes, because when I did it up proper and had all the good lights and a good camera and went and got a blowout and got lipstick that matched my skin tone, and so it'll look radically different compared to this video. But I want to expound upon the learn to walk before you try to run type of a deal and nail some of the fundamentals down on this printer and other printers, but we're talking about this printer, so we're going to do it on this printer. So since this was a quick and dirty last minute thing, I'm going to try to give proper credit to everyone if they also had the same or similar idea somewhere else on the internet, like the Kingroon Facebook group and that type of stuff. Sorry if I miss anything. It's not malicious. I'm actually going to do a finishing pass and go through this and try to look up some of those sources as time permits. Checking and fixing the alignment of the machine, flashing the newest firmware file, stuff that I wasn't going to spend a whole lot of time on. Not that it wouldn't be useful to people, but I had more fun things that I wanted to do. And in answer to some others of you in the comments who have said, like, why are you bother going in depth on these cheesy things? Like, I did a 6-part series on the ramps board. People are like, wow, that was like a $10 board and we know it's not very good. Like, why did you do it? The point is not saying this is crap, don't get it. The point is taking you on the journey. Sure, I could bottom line it, give it a thumbs up, a thumbs down, and then bullet points with the positives and the negatives. But for people who may have ended up with one of these for some reason or another, I don't know. We just had like 11/11 and Cyber Monday and Black Friday. Maybe your auntie wanted to get you a 3D printer because you expressed interest. She sorted by price, and this was the cheapest one. Like I said, I got mine for like $89 or something like that at the time. Or maybe you just wanted to try out something with linear rails and see how that worked out as your third printer to print keychains while you're doing real work on the other ones. I don't know, but the point is it may have dropped in your lap somehow and you're looking for somebody to walk you through their experience with it. And there's a place for big fancy machines with a specific built purpose that quote unquote just work. Then there's also a place for the cheapy stuff, maybe stripped down bare bones things like the Ender, like the ramps board, like other things like that. Let me explain. It's very possible you look at like an Ultimaker, or you look like a Prusa and you say, yes, every feature on that machine speaks to me. This is perfect what I need it for. Where have you been all my life? Or you could look at some machine and say, I don't need half that stuff, man. If it was like $200 cheaper and didn't have it, that would be great. So the problem is when you get into like the culture of a particular thing, whether it's mechanical keyboards or mice or graphics cards or printers or cars or cell phones or whatever, you get this thing that happens naturally in the course of competition called feature creep. And you just have like a little widget here and a little gizmo there, and you don't want these to go to reviewers, and then they have a little talking point where they can say, well, you know, this product doesn't have the left-handed smoke shifter that this one does, so, you know, hey, I can't give it a 9, or I can't give it a 10 out of 10. You know, the tech is usually the worst. Like, I mean, freaking cell phones these days. It's like your phone's got 4 cameras, it's waterproof to 70 meters, high-speed processing, insane pixel density, haptic feedback, wireless charging, biometric locks, nanometer wave 5G. You know, it's like, this is my phone. It's practically a brick. See how square that is? Yeah, I'm lame. It's paid for, it makes calls, and it has a headphone jack. Anyways, so when it comes to 3D printing, it's still a developing market, the desktop 3D printing stuff. Very useful tool, but there are so many people who do so many different things. Like, one person may want a printer to print giant, like, architectural models to place on a scale. One person might be prototyping little mechanical widgets before they send it off to a CNC. You know, other person might be making angel wings for a cosplay outfit. It varyingly, like, drastically varied needs across the board. And if I decide to take a printer because I just want to print with a big old volcano nozzle, 1 millimeter thick layer bronze filament to make busts of Picard doing a face palm and sell it to nerds on Etsy, right? Like, I don't want to have to strip all your stupid fancy extruder and all that crap off of that just so I could build it up to what I want anyway. So yeah, that's where the cheap printers come in. We now return you to your previously recorded segment. Sorry, I lied about the lipstick. Pre-assembling a printer doesn't really help if it's not done right. So if you recall from the previous videos, one of the problems I had was that we were printing like kind of slanty objects, and we were printing objects that weren't particularly round and they didn't fit into each other. So we have to fix that by making sure that the printer is square and everything is aligned. We had this problem with the X gantry on the Ender as well, and I kind of presented my solution for that, which was just drill a hole through the Z-axis so you can loosen up one bolt, then find 2 evenly sized things to square the gantry up with the frame. With this, it's a little bit tougher because we have a big one-piece molded X-axis, so you can't really do a whole lot with that. But you can use the screws on the wheels to make sure that that is at least parallel to the plane of our Z-axis extrusion, pardon the terrible drawing. And as long as that's the case, then we can go ahead and move the linear rails around a little bit, change the angles, and make sure that everything is square. And there was a pictorial guide on the Facebook group for this, but I'm going to show you how I did it, and maybe you'll get a little bit more out of it. For demonstration, I'm going to be using this triangle square, it's just a drafting triangle. If you don't have one or don't want to spend the bucks to get one, I always try to present the cheapest ways possible of doing this. And paper is very square, which I'm just demonstrating here in this picture. So if you just want to use that to check your alignment visually, you can do it with paper. Like, I did it. It's just more convenient to have something rigid that you can push against an axis. And unfortunately, to adjust this, and well, to check it and adjust it, I had to take the whole freaking thing apart. So I'm just pressing this square up against the vertical extrusion so that you can see my linear rail does align with it vertically, so that's good. If it's off a little bit, you could probably use the screws in the back of the wheels to tweak that somewhat, like to a certain extent. However, you can also see that the Y-axis linear rail is not aligned, unfortunately. So time to cross our fingers and hope we have enough wiggle room after we loosen these bolts, and unfortunately we did not. We need a couple more degrees. So what does that mean? Well, here begins the lessons in critical thinking, taking problems as they present themselves and solving them with whatever the heck we have at hand. For example, a semi-precision impact adjuster such as pictured here may not necessarily be the best method for things, but sometimes it's all you have. For example, it probably won't surprise you that I do not have a metal lathe in my apartment, nor do I have access to one because of the global pandemic. But I want to make the head on these bolts narrower so I can give myself a little bit more wiggle jiggle. So let's go cheap and dirty. I'm going to take this screw, stick it in the truck of this cordless drill, and then grab a file, not the kind of file that you clean with a wire brush and you keep in a soft leather pouch, but the kind of file that you do this crazy crap to. And it's very possible you won't need to go to these measures on your machine, and it's also very possible that you have 3mm screws with narrower heads, but I don't, so yeah, extreme violence it is. But fortunately that gave me the angle that I needed, and now we have a perfectly aligned rail. See, we're not just working on 3D printers, we're learning improvisation and general problem solving skills. You gotta work with what you got sometimes. And speaking of which, what we actually want is for our x-axis and our z-axis to be a perfect 90-degree angle. And this goes for every 3D printer, not just this one. Unfortunately here we have a little bit of an offset between our rail and our z-axis, as in things are in the way, so it's a little bit tough to get something in there. I took the whole thing apart and used this big old drafting triangle to get it all squared up. That worked fine. I would say like grab any old square thing, but you can't always trust things to be square, and unfortunately something like paper is too floppy to do this with. But if you had a smaller triangle or square, you might be able to even shove that in without having to take your X carriage apart. And in the end, I got it so that my 0 point was what would be the middle of the build plate. All the way to the right extreme was minus 0.03. All the way to the left of the plate was 0.03 positive. That's about as reasonably close as I could get it. Then I reran the tests that I ran before to see if our round peg would fit in our round hole like it's supposed to, and this time they fit perfectly. It was actually a little bit of clearance, so I think I was under extruding a little bit. That's cheating. So I decided to go ahead and do it on a much larger scale. That way it's more likely and easier to see if there's any kind of eccentricity going on, if you have ovalized holes or anything like that. Other than a little bit of wisping, the prints came out pretty beautifully and they fit absolutely perfectly. So a little bit snug, but nothing that, ever so slight tweak on the slicer settings wouldn't fix. And more importantly, they were round. I also printed a big tall 100mm column to make sure that there was no, leaning tower or Pisa action going on, and there wasn't. It was square. Also, you can see there's no surface abnormalities as in like Z-wobble or anything like that. Just in this reflection, you can see I was messing around with the temperature and the extrusion. I ended up switching to a pillow box setup, so I'll talk about that in the next video too as an alternative. Real quick, let's do a slicer setup. This next section is going to be kind of for the noobs, but since there wasn't a slicer profile built into this, and I did have people in the questions that were like, help, I don't even know how to put the software on my computer to make things go to the printer. So I'll touch on that very briefly, show you how to make a very general template for this machine, and then you could mess around with it and tweak as necessary. All right, here's my little 2 cents, but once you get Cura installed, go over to Marketplace button in the upper right corner, and I'll show you what I have. Sidebar GUI and linear advanced settings in case we need that in the future. Both plugins by Field of View. Thank you, Field of View. Very, very helpful. The sidebar gives you all this loveliness on the right side. Now go up to settings and then select printer, add printer. That'll bring up this. Click add a nano networked printer and then go down to custom. Give it a name, Kingroon KP3s, click add. Then you're just going to add in the details for the printer. So at least we want to make it the same axis size. It gives you dummy start and NG code. You can tweak that to your liking, but we're just doing the basic stuff right now. Print head settings, this is going to have to be set to whatever print head you want there. Mine is different than yours because I'm messing around with it. Extruder, all you really have to change is 1.75 for your filament because we're not using the Ultimaker 1.843272, whatever the heck that stupid size is. Then be a boss. Next to search settings, there's these 3 lines. Click all so you get all of the lovely settings that you can play around with. It's overwhelming at first, but just deal with it. It's better you learn it. Then in the upper right hand corner, they're going to have some presets. These are not going to be set to our magic layer heights. So just grab one. Fine, I'd say 0.16. You can go up and down from there. Initial layer height 0.28 instead of 0.3. That's going to land us on a magic layer. 0.24 works too. 0.2. Go down to acceleration control and you can tweak all of that. You see their presets are very fast. You don't have to do it, but it won't give you proper print times if you don't. Retraction distance you'll have to set to your extruder minus 0.75 millimeters right now. I slowed down the retraction speed, slowed down the prime speed a little bit more, and then jerk you see is also set more aggressive than we would on this machine. That's stuff that you're going to have to fill in. I'm just kind of showing you where it is and all the options. So yeah, that's the quickest tutorial for you there. Let's slow it down a little bit and talk about the firmware. So in the last video, I said this is kind of a mystery meat firmware. I did a couple things that I'll show you and confirm that it is some kind of version of Marlin 1.0. I'm not overly concerned that they haven't uploaded the source files to this because that's really old. Like, it's functional, but I'm not going to, if I'm going to do a custom rebuild of a firmware, I'm not going to use years old version of a firmware that's updated several times every day. I'm just going to roll the new stuff. So your choices are, if you're like a real beginner, you don't want to mess with that stuff, or you like the old system, the way their bootloader works is they did it kind of like SmoothieWare, where it'll recognize a particular configuration file, write those configurations to the EEPROM, and then that's going to overwrite the settings that are in the firmware. Option 2 is you could go to the Kingroon Facebook group, which is, to view anything or download anything, you need a Facebook account, and people might not have that. Regardless, it's pretty easy to update the firmware on this. You just take the precompiled binary and the configuration files, drop on the SD card, plunk them in the machine, start it up, you're good to go. It'll automatically update itself. But when I flashed it, I tried to flash the binary and the configuration file at the same time, and that didn't work. So it flashed the binary, but the steps were all wrong. So obviously it didn't write the configuration file, or it wasn't respecting those values in the EEPROM. So shut it down. It booted it back up with the configuration file on there. It had changed the name of the configuration file, so I had to change it back to TXT, put it back in there, booted it back up, let it do its thing, powered it down, booted it back up again, and then it was fine. So yeah, just bear that in mind. Thought it'd be a useful tip for ya. So as I mentioned, I didn't have a configuration file, so I borrowed one from the Facebook group. Unfortunately, it was kind of garbled because of translation issues with the fonts. So this one I grabbed from MakerBase's GitHub and changed all the settings to the stock KP3s settings, and then that's what I'm working off of and tweaking as I go along. So I will upload my setup in the next video. So if you don't have one of these files with a nice English notes, then here you go, you can have that one. You just have to wait till the next video. But if you're using that original firmware, this is where you're going to make the changes to your maximum feed rate, your accelerations, like your stock firmware accelerations, the jerk settings that you can't get to, such as the extruder, which is kind of important. If you're using the stock extruder, you could turn the jerk down real low, turn the acceleration down real low, so you're not going to be slipping filament. But as far as the Kingroon firmware bin, before I took a more reasonable route, I dropped it into a hex editor just to look for human readable notes, and it does identify as Marlin, and there are a whole bunch of Marlin specific commands, so we know what we need to know. Unfortunately, we don't have the source code for the bootloader, so there's no chance of massaging that to work with Marlin 2, but what are you going to do? Baby steps. So we do at least have a hex file of the bootloader that we can flash if we, bork it so we didn't break the board. And speaking of source code, we do have the MKS Robin Nano Marlin 2.0 source code that we can use as a platform to build a KP3s profile from. Someone in the comments said there is already a KP3s profile. I didn't see it, but I'll have to take another look. If not, it's not too big a deal to build one up. And then next to your option would be like rolling your own jazz from scratch. Like if you want to stay absolute bleeding edge with Marlin, or if you're like, screw that, I want to go, Clipper or RepRap firmware or Smoothie or whatever. Ultimately, that's the option I'm going to take. Just whatever current Marlin version there is, I'm just going to plunk that on there. I decided to use the Marlin new graphical UI touchscreen stuff that they put in the last few months. I haven't looked into that too much, and I had some problems building with various options, such as it works, but it doesn't like being rotated because the screen on this printer is in portrait mode rather than landscape. It's possible that just defaults to landscape mode, and then the graphical elements and the touchscreen positions are placed depending on those coordinates. Rotating it didn't work for me. Maybe that's a bug. Maybe it needs to be programmed from scratch for the other mode. But regardless, it does work fine in the landscape orientation. Unfortunately, on this printer, it's just rotated 90 degrees. I just don't have the time for the troubleshooting and program from scratch right now if I want to get this out on any kind of timely schedule. We're also kind of spoiled for choice these days when it comes to UIs, which is a good problem to have, I guess, but it is a lot of options to try out. Also, as I may or may not have mentioned before, TH3D Studio appears to have a unified firmware version for the original KP3. It doesn't look like they have one for the KP3s, I'm sure you could massage it into shape if you want, if you're using their, ecosystem and their add-on parts and that type of thing. So I just thought I would mention that here. What I ended up doing was I grabbed the most recent pre-compiled binary for the firmware off of the Kingroon Facebook group, which I think was from August. Then I took the configuration file from MakerBase's Robin Nano, used the firmware bin as it was. Like, I figured that's as stock as I could get, but updated, and then just stuck the configuration files in a diff tool like Meld. Tried to look at the differences, although it's goofy because all that blah, blah, blah spewage on the right-hand side, that all comes up as a difference. But regardless, got it so that they were basically one per one, reconfigured it for my PID values and the E-steps, and then, there you go, I flashed that. As in, that's the option that I choose for all the testing in this video. For the mod video, I'm probably just going to use Sideways Marlin. As far as the print resume, there was a question in the comments, or a comment in the questions, whatever, a comment in the comments, that made me want to try a few things. And in the process of that, I don't know if that the exact problem that the commenter was having was the issue, but in the process of that, I discovered that depending on the options you have, it can mess it up in one way or another, and I'll show you the wacky things that happen. Just as a refresher to what happened last time, this was what happened when I tested the power resume, or the print resume power off feature. As you recall, the extruder just kind of didn't work right. It twitched, but it wasn't really doing anything after I did the extrude. So, working off of that tip in the comments, I tried out a couple things with the configuration file, taking the min temp for the extruder and dropping that down a bit, thinking maybe if we were fluctuating over and under that threshold, it would be turning off the extruder, and we may or may not get the warning that we're supposed to, because I don't think this was a function of Marlin 1. This may have been like backported in some way. I'm not positive. It's been a long time. But I know that in the modern version of Marlin, the prevent cold extrusion macro feeds into a couple functions with their separate header file for the print resume, and it'll grant permissions so that you don't run into this sort of a problem. So you might be onto something there. I did I did some searches in the older version, and I couldn't find the same function, so that may be an indication. But regardless, I played on that commenter's hunch, and I wanted to see what would happen if we killed the power, but we did not drop below the cold extrusion threshold. And that actually worked fine. You could see the little Sharpie mark where I marked on the cube where it had stopped printing. But yeah, it resumed printing just fine after that. So thumbs up, I guess. But the chances are that your hot end is not going to drop below that levels is pretty slim. So I did it again, waited for the hot end to cool all the way down and then heat all the way back up, and this time we did not have an extruder that did absolutely nothing or just twitch back and forth like it did in the original testing. This time the extruder just went crazy. I'll move the camera and show you this feeder wheel. Look at that thing go. It's just freaking out. And before it completely chewed its way through the freaking filament, it managed to make quite a spectacular pool on top of the print. So I guess the bottom line is, as long as you don't drop below your cold extrusion temperature, it seems to resume okay. At least it did in my test, so I guess bear that in mind. I don't, strictly speaking, think that print resume is necessary on a machine this small. Like, if you do, if that's something that you like, then cool. But I don't think, like, if I'm going to roll my own custom firmware for this, I'm probably just going to cut print resume off. And the new firmware binary, in case you were wondering, didn't really help with the USB connectivity. I still had the command unknown problem, but I did that thing I do when I have a misbehaving USB peripheral, which is just grab a bunch of old hubs from a crate and plug them in and out until I find one where it seems to behave. Found one where it was behaving, so at least well enough that I could do the PID tuning that I mentioned earlier. So copy those into my configuration, flash them on the board, and yeah. However, with the new MakerBase binary and with my custom Marlin binary, I was able to get the USB working perfectly fine, and I even did a tethered print on it, which went pretty much without a hitch. So there you go. That'll get us a long way toward better printing, or at least more useful printing, as far as making sure that circles are round and squares are square and cubes are cubical. The actual mods, next video. So we're going to cover fans, replacing the fans, fan mods, various ways you could do that to make it, you know, more modular and easier to use. We're going to look into the rails, right? The quality of the rails on here. Replace some of the bearings. That's one of the reasons that this video took a week longer than it should have, was because I was stalling so that this could show up in the mail because FedEx screwed me again. We're going to look at various ducts. I may get into like a duct theory, static pressure. I don't know. It depends how much time we have. Various extruder options, simple things like bed insulation. We're going to look into the electronics and how they have everything wired on the board, because MakerBase has a GitHub with all of those files on it for this board, or at least close enough for jazz. So we have the schematics for the drivers, we have the pinouts, we have the defaults, we have instructions. There's a whole lot of information there. Everything except the bootloader, unfortunately. But it will allow us to at least go through and see if we can optimize things the best we can, even though we don't have the chips running in smart mode. I'll have to see if there's some spare GPIO pins somewhere. Maybe we can sneak smart mode in there. We'll have to see. And hopefully I'll even have some time, since it's a socketed board, to slip in some drivers from like Pololu and Panikit and see if that deals with any some of the weird little like surface abnormalities and whatnot that pop up from time to time. So this is Alex signing off. Until the next video, get out there and make something awesome. Yeah, screw your magnets. I'm making another build surface.